Okay, question 4. We're going to be using the Newton-Raphson method to solve equations. So, we are told if the equation x cubed minus 3x add 1 equals 0 has 3 distinct roots. We want to show that one of the roots lies between x equals minus 2 and x equals minus 1. So if a root does lie between those two values of x, we will see a change of sign for the value of the function when x is minus 2 to when x is minus 1. So first up, let's let our expression be f of x. So let f of x equal x cubed minus 3x add 1. Then it just lets us show easily what we are substituting into the expression. So f of minus 2 is equal to, well, minus 2 cubed is minus 8. Minus 3 lots of minus 2 is add 6, add 1. So we got minus 8, add 7, which is minus 1. Then let's do f of minus 1. Now that's going to give us minus 1. Add 3, add 1. Now that's going to give us 3. Okay, so we do have our change of sign as we need for there to be a root between two x values. We also need to mention something else about the curve, and that is that it is a continuous curve. So we do need to state that in our argument that the curve is continuous. So we can say that there is a change of sign between f of minus 2 and f of minus 1 and the curve is continuous. So a root lies between x equals minus 2 and minus 1. Cool. Okay, now for part B, using x1 equals minus 2 as the first approximation to one of the roots, use the Newton-Raphson method to find x2, the second approximation to the root. So we are given Newton-Raphson in the formula booklet, should be on screen. So xn plus 1 is equal to xn minus f of xn over f dashed of xn. So we first of all need to find the derivative. So f dashed of x is gonna be 3x squared minus 3. Okay, so we are going to use then x1 is minus 2 f of x1. We already know that, we did that up here. So f of minus 2 is minus 1. And f dashed of x1, well, that's going to be the value of f dashed of x when x is equal to minus 2. So minus 2 squared is 4. 3 times 4 is 12. Minus 3 is 9. So x2 is equal to minus 2 minus 1 over 9, which is minus 2 and 1/9, which is minus 17 over 9. Cool. Okay, then part C asks us to explain why the Newton-Raphson method fails if the first approximation x1 is minus 1. So let's see what would happen. So if x1 is minus 1, we know that f of x1, we just worked it out. F of minus 1 is 3. And then what would f dashed of x1 be? So if we substitute x equals minus 1 into our derivative, which is this, minus 1 squared is 1, times 3 is 3, minus 3 is 0. So that is our problem. We would get that x2 is equal to minus 1 minus 3 over 0. So we can't do that because you can't divide by 0. So we would want to say that f dashed of x1 would equal 0, and we can't, so we can't calculate x2. Anything like that would be fine.